All right, in the instruction book on page 22 is lesson 3, rational and irrational numbers. We're going to start with rational numbers. Rational numbers are numbers that can be written as the quotient of two integers. Now, if you need something else on your graphic organizer, there is the definition of rational numbers. Numbers that can be written as the quotient of two integers. Now, quotient is division, which sets it up into a fraction. So if you can write a number as a fraction, it's a rational number. Any number that could be written as a fraction whose numerator and denominator are integers is also a rational number. Okay, rational numbers. Any number that can be written as a fraction. Doesn't mean it is a fraction. It means you could make it a fraction if you wanted to. Every integer, whole number, and natural number is a rational number. Now, natural numbers are your counting numbers. This was on your graphic organizer. Think about what numbers you learned to count with when you started pre-K or kindergarten. Okay, you started at 1. 1, 2, 3, 4, 5. Okay, those are your counting numbers. They're natural. They're the ones you naturally learn. Somewhere around first or second grade, that's when you move into the whole numbers. Whole numbers include all of the natural numbers and 0. Okay, somewhere around first grade, you learn the concept of 0. Those are your whole numbers. Whole numbers are the numbers we prefer. They're easy to work with. Integers are all of the counting numbers, or all of the natural numbers, and 0, and all of the negative natural numbers.
I can't see that from here. Okay.
You can write every integer, whole number, or natural number as a fraction. So they are all rational numbers. Now, all of these numbers are just numbers you're used to using. They don't have a decimal, they don't have a fraction, but they can be written as one. If you have a whole number and you want to make it a fraction, you just put it over a 1. It's a fraction. That makes it rational. The square root of a perfect square is also a rational number. Okay, if you see square root of 4, you might not think that that's an integer, but if you simplify it, the square root of 4 is 2, which is a whole number. Okay, it is a whole number. It's a natural number. So they're just showing you that you can simplify these to make them into other forms of numbers. The last type of number that falls into rational numbers is the terminating, no, there's one more. Terminating decimals. Okay, terminating decimals are the easy ones because you can see the end. Okay, you know where they stop. You can write those as a fraction because you just decide their place value and then you turn it into a fraction. 0.4 is 4/10, so you would write it as 4 over 10. 0.75 is 75 hundredths, so you would write it as 75 over 100. The radical down here, the square root of 0.16, you might not recognize that as a perfect square, but 16 should set off an alarm, okay? You know 16 is a perfect square. Its square root is 4. You just have to decide where that decimal place would go. And it is 4/10, and that could also be written as a fraction. The last one that goes into the rational number category is your repeating decimals. Every repeating decimal is a rational number. Now, a repeating decimal is a rational number because you can write every repeating decimal as a fraction. It is not a simple process, but it is a process that you have to learn to do. They are giving us an example of the repeating decimal 0.3. Now you should all know that that line over top means that this number was just repeating over and over and over forever. When you have something that repeats, you find the repeating portion, you draw a line over it, and you get to eliminate everything else. Okay, it makes it easier to use. Now they want us to take 0.3 and write it as a fraction. Okay, we cannot write it as 3/10 because it has more. It's got a 1/3 more after that, right? That's why we have to be able to convert this. So it is not 3/10. Set your repeating decimal equal to a variable. Okay, they're setting it equal to x. X equals 0.3 repeating. This will be your first equation. Okay, that's your first equation. Now you have to make the second equation. You make the second equation by deciding the place value of the repeating portion. Since this is the 10th place, we're going to multiply both sides of this by 10. 10 times x is 10x, and 10 times 0.3, repeating, is 3.3 repeating. This is our second equation. Once you have the two equations, you're going to subtract them from each other. What we're creating is whole numbers without the repeating portion. So you would take the 10x from the second equation, and you're going to subtract x from the first equation. You take the 3.3 repeating from the second equation, and we subtract the 0.3 repeating from the second equation. Once you get here, you're just solving, and when you get done, you will be in fraction form. 10x minus x makes 9x. 3.3 repeating minus the 0.3 repeating leaves you with just 3. Notice how we got rid of that mess of a decimal. Okay, we're making it numbers we know how to work with. Now we're solving for x. We divide by 9. 9 divided by 9 eliminates. 3 divided by 9 is 3 over 9, which also reduces to 1/3. So 0.3 repeating is equal to 1/3. All right, here's another example. This is x equals 0.512 repeating. The repeating portion is the 0.512. We want to get rid of the repeating part so we can write it as a fraction. Now they've already set it equal to x, so this is our first equation. To get the second equation, we're going to multiply by the place value of the repeating portion. Not 10, not 100, but 1,000, because this is to the thousandth place. So we'll take 1,000 times x equals 0.512 repeating. We're multiplying both sides by 1,000. So we'll have 1,000 times x is 1,000x. And we'll have 1,000 times that 0.512 repeating, which becomes 512.512 repeating. And that gives us our second equation. Now we're going to subtract. Okay, we're going to subtract. The first equation will be taken away from the second equation. So we'll have 1,000x from the second equation minus 1x from the first equation equals 512.512 repeating minus the 0.512 repeating from the first equation. Second equation minus first, second equation minus first. Now when you simplify this, you're going to eliminate the repeating decimal. 1,000 minus 1 is 999x. And 512.512 repeating minus the 0.512 repeating gives you 512 whole number. Now we're just going to solve for x, and we're going to divide both sides by 999. That leaves us with x equals 512 over 999 will not repeat, so that is just the answer. 512 over 999. And that's it. All right, number 1 at the bottom of the page, what fraction is equivalent to 5.1 and is it a rational number? Now, 5.1, without making it a fraction, is this a rational number? Yes, it is, because it is a terminating decimal. It has an end. We can see the end, 5.1, period, that's all. So it is a rational number. They just want to know what fraction is it equivalent to. Well, whole number 5 and 1/10. That would be a fraction form. You could also write it as an improper fraction. 5 times 10 is 50 plus 1 is 51/10. So since we can also write it as a fraction, yes, it is a rational number. Can be written as a fraction. Or you could have said it is a terminating decimal. Either of those answers would be correct. I'm okay with either of those.